Now we're going to answer all of the same questions for cosine. So the cosine curve, let's just remind ourselves, is this picture right here up at the top. Okay. And it looks like two big U's here. The domain, it goes on and on forever, left and right on the x-axis. So the domain is all reals. And then the range, just like the sine curve, goes from -1 to 1. It never goes above +1. I'll show you that. It never goes above +1, and it never goes below -1. It's always somewhere in between -1 and 1. Okay. The zeros. Okay, we're going to go ahead and look at that graph again. Let's look at the zeros. -3 pi over 2, -1 pi over 2, 1 pi over 2, 3 pi over 2. The next one will be 5 pi over 2, 7 pi over 2. So all the odd multiples of pi over 2. So odd multiples of pi over 2. The period, just like we said with sine, it takes a full 2 pi before it repeats, and I'll show you that in case you didn't understand that before. So I could, I guess, start here, and I have my giant U, and then it repeats. And every time it takes 2 pi before it repeats. So from 0 to 2 pi is a distance of 2 pi. From -2 pi to 0 is also a distance of 2 pi. So it's every 2 pi the pattern repeats. Okay, let's go ahead and write that down. Sorry, not being real smooth there, am I? And now let's decide if it's even, odd, or neither. When I look at this, and as far as its symmetry, it is reflection symmetric over the y-axis, which means it is even. So I'll write even, because it is reflection symmetric over the y-axis. Okay. All right, for what values of x between 0 and -2 pi are both cosine of x and sine of x negative? So we want to know, when are they both negative? So we're looking at the cosine. Between 0 and -2 pi, we want both cosine and sine to be negative. All right, I can look at my graph to determine that, and then I'm going to show you another way to determine it as well. So when I'm looking at these graphs, 0 to 2 pi means let's look just at that left side of the graph where we're from 0 to 2 pi. So I'm going to cover this up right here. We're just looking from here to here, and we want both cosine and sine to be negative. Well, from 0 to -2 pi, cosine is positive, sine is negative. From -pi over 2 to -pi, cosine is negative and sine is negative. So we know that from -pi over 2 to -pi, they're both negative. Then here, cosine is negative, but now sine is positive. And then in this quadrant, they're both positive. So the only place I see that they're both below the x-axis, which means they're negative, is from -pi over 2. This is where you can, well, one of the easiest ways to look at it is that I want both of them to be above or below. Pink is above, pink is below. So they're not both negative. One's positive, one's negative. Yellow is below, and yellow is below. Both negative. Blue is below, but blue is above here. One negative, one positive. Both of the greens are above, so they're both positive. So right here, from -pi over 2 to -pi, that is when they are both negative. From -pi over 2, I guess, actually, it would be from negative pi to negative pi over 2, because negative pi is smaller because it's a larger. Negative is actually a smaller number, so it's from negative pi to negative pi over 2. If I didn't look at the graphs and I thought about my unit circle, when are they both negative? We know that it's in quadrant 3. This is my negative quadrant. So honestly, for me, that's how I would answer this question. I would just look at the unit circle and say, well, I know it's in quadrant 3. And if I'm not thinking of it as 0 to 2 pi, but negative 2 pi to 0 going this direction, that would be from negative pi over 2 to negative pi. And that's just probably how I would have figured it out, is actually just looked at the unit circle and known that it's in this quadrant, which is from negative pi over 2 to negative pi, which is what I have written right here. Okay. All right, our next question, number 9, one solution to the equation sine of theta equals 0.564 is theta is approximately 0.5999. So they're saying, when do we have a sine that's 0.5654? That's when theta is 0.599. So in other words, the sine of 0.599 is equal to 0.564. You could check this on the calculator. Let's see, just to make sure we understand this. I want to first make sure my calculator's in radians, and it is. Okay. So sine of 0.599, they're saying, sorry, I realized that when I checked my calculator, it was highlighted on degrees, not radians. That's why I got the wrong answer, which is really good that I checked it. So I've now switched my calculator to radians. Now let's do sine of 0.599. And some of you might have realized, hey, Miss Lindsay, your calculator is on degrees, not radians. Well, I figured that out. And that would be 0.564, because the 8 would bump the 3 to a 4. Okay, so indeed, the sine of 0.599 is approximately 0.564. Find two other solutions closest to this value. Well, remember, we can go around the circle again. So it could be sine of 0.599 and go around to 2 pi. Or if I want them closest, I could do 0.599 and go the other direction, 2 pi. Those would be the ones that are closest. Okay, and so that would be, let's look at, that would be sine of, I'm going to go ahead and use my calculator, 0.599 plus 2 pi is 6.882. So this would be sine of 6.882. So that's one of my answers, that theta would be 6.882. And then I want 0.599 minus 2 pi, and that would be negative 5.684. Negative 5.684. So those are my other values, that theta would be 6.882 or negative 5.684. Okay, let's go to number 10. Here's where we're going to be answering questions about the sine, cosine, and tangent. Not tangent, actually they just want to know about sine and cosine. Identify which, if either of the parent sine and cosine functions have graphs with the given characteristic. So again, the graphs that we're thinking about are from this page right here. These are the two graphs we're looking at, cosine and sine, and these are the questions that we want to answer. Let's go ahead and do that. All right. Symmetry with respect to the origin. Well, I'm going to look right up here at this table. The sine graph was odd. It was rotation symmetric around the origin. But that's rotation symmetric. Usually, I guess that they could be talking rotation symmetry. I would also think of cosine. The way they have it written, it's very, I don't like the way it just says symmetry with respect to the origin. If you reflected over the origin, you would actually also get the cosine graph. I guess they're meaning rotation symmetric. They should have written that, but we'll say with respect to the origin is my sine graph because that was odd. Symmetry with respect to the x-axis. Let's look. We never talked about that. That means if we would fold it over the x-axis, well, neither of them will be symmetric because if you folded this, you'd have a curve down here, and this curve would be up here. It would not look like the same graph. Same thing with sine. So neither of them has symmetry with respect to the x-axis. Symmetry with respect to the y-axis we know is cosine because we said that was reflection symmetric over the y-axis, so that's cosine. Horizontal asymptotes. Neither sine or cosine had asymptotes. X-intercepts at integer multiples of pi. Right up here in my table, integer multiples of pi. That was sine. And a y-intercept of -1. Let's look. That's not in my table. Y-intercept of -1. That's neither of them goes through the y-axis at -1. So that one would also be neither. All right, I'm hoping that helping you through this lesson master will be enough of a guide so that you can complete the other lesson masters on your own.